Xin chào các bạn, Etabs phiên bản 22 có rất nhiều tính năng mới, trong đó kỹ sư xây dựng Việt Nam quan tâm nhất đó là tính năng tính toán và gán tải trọng gió tự động theo tiêu chuẩn Việt Nam 273722023. Đây là tính năng rất hay của Etabs phiên bản 22, giúp các kỹ sư không phải đau đầu khi tính tải trọng gió. Các bạn có thể tải file Excel tính gió theo tiêu chuẩn Việt Nam 273722023 mà htcl đã chia sẻ hoặc trong mô tả video hoặc trong comment bài viết này để so sánh với kết quả Etabs tính toán. Các bạn đừng quên đăng ký kênh YouTube, follow TikTok để theo dõi thông tin mới nhất của mình nhé. Chúc các bạn download và áp dụng công việc thành công.
Start with the new floor vibration option. Under the Define menu, if you go to Floor Vibrations Excitation Sets, here you can define an excitation set, which refers to a set of input values required by the program for the analysis of floor vibrations in steel frame structures. So if we click on Add New Excitation Set, so this set includes key information such as location of the vibration source and the location where the vibration's impact is measured. Also other parameters like damping value and associated modal case. So we'll just enter in a couple joints here. Click OK. Now the excitation sets have been defined. Now if we run the analysis, to view the floor vibration results, we'll go to Display, Floor Vibration Results, Walking Vibration. So the Walking Vibration Analysis form enables the visualization of the floor vibration analysis results, specifically for the excitation sets marked with analysis type Walking. Here we have the analysis method, Design Guide 11. Floor occupancy type denotes the occupancy usage of the floor being analyzed. We have pedestrian body weight, equivalent viscous damping. To ensure consistency, the damping value is taken from the modal damping used in the excitation set's steady state load case. So if we go down to the analysis summary, each excitation set may have two associated rows in the table, one to display the results related to the low frequencies and another to the higher frequencies. Max, FRF, and dominant frequency. FRF is frequency response function. So here we have the excitation joint, response joint, DCR, design capacity ratio, a comparison of the predicted peak sinus acceleration and how it compares to the recommended limits for human comfort. The additional details panel provide the user with information related to the calculations. So here we have modal data, natural frequencies and periods of the current model, FRF data, a plot of acceleration measured at the response joint due to the loads applied through the steady state load case at the excitation joint. And the comfort limit plot, a plot that displays predicted acceleration values alongside recommended human comfort limits. So in this plot, the predicted acceleration is represented by a point and the comfort limit by a line. If all the points fall below the comfort line, the predicted accelerations are unlikely to cause human discomfort. Now, let's take a look at what new steel design and concrete design codes have been included. So under the Design menu, we'll take a look at steel frame design, view revised preferences. Under Steel Design Code, you can see AISC 36022 code has been included. So for steel frame design, including AISC 34122 seismic provisions, also for composite beam design, composite columns, as well as steel connection design, AISC 36022 has been included. Also, for composite column design, if we go to View Revised Preferences, we can see that the CSA S1619 code has been included as well. So if we go down to steel joist design, new joist design code SJ1-100 for 2020 has been included. Also, a new type of steel joist section has been added, custom joist section, whose definition includes component section data. So a detailed calculation report has been implemented. Once you run the analysis and design, you can access reports quite easily. So now if we look at concrete frame design, an enhancement was made to add joint shear design for ACI 31819 concrete frame design. Joint shear is now performed for ordinary moment frames in seismic category B using the nominal flexure strength of the beams. This was also added for intermediate moment frames as well as special moment frames. Next, let's talk about hinges. So an enhancement was made to add the capability for automatic generation of frame nonlinear hinges based upon recommendations of ASCE 4123. Let me show you where that's located. So if we go to Assign, Frame, Hinges, if you click on Add Hinge for under the Frame Hinge assignment data, here you can see all the new codes that have been added. So for steel beam, column, and brace hinges using the reference standard ASCE 342.22 as specified in the ASCE 4123 Chapter 9. Also, this has been implemented for concrete beam, column, shear wall, and coupling beam hinges using the reference standard ACI 369.122 as specified in ASCE 4123 Chapter 10. So you can see here all the options available to the user. Okay, let's take a look at auto wind load calculations. To define them, we'll go to Define, Load Patterns. We'll define a wind load. And for auto lateral load, these are all the codes that have been included. You can see Australia, New Zealand 1170/2021 has been now included. If we modify lateral load, you can see here that we can define wind exposure parameters, wind coefficients, all associated with the code. So when you run the analysis, we can take a look at a nice output report. To access the reports, we'll click on the Reports tab under the Model Explorer. Double-click on the project report to generate it. So if we scroll down, you can see under Loads, Auto Wind Loading, here is the Australia-New Zealand code calculations. So as you can see, we have all the exposure parameters, factors and coefficients, lateral loading equations, as well as applied story forces. This can be found in a nice tabular format as well. Next, let's take a look at new material libraries and database that have been included. So under Define Material Properties, I can add a new material. And for steel material type, you can see these are the standards that have been included. The latest one, ASTM A1065, as well as 1065 for metric, is now included in the program. And if I click on Material Property Data, you can see all the associated material weight and mass and mechanical property data has now been included. Next, let's take a look at the enhancement that has been made to speed up joist design by using parallel processing. This option can be found underneath the Analyze menu, Advanced Design and Response Recovery options. Here you can see number of threads for design, and there are two options available: program determined and user specified. Essentially, this sets the maximum number of threads design algorithms can use. Program determined option is the default and allows design algorithms to use up to the number of physical cores simultaneous threads. The actual number of threads the design will use is displayed next to the option. So for user specified option, this enables you to explicitly specify the number of threads design algorithms can use. Each additional thread used for design requires additional memory, hence must be taken into consideration when specifying this value. It's typically recommended not to exceed the number of physical cores present on the system. Okay, lastly, there's been a new response spectrum function that has been included. To view that, we'll go to Define, Functions, Response Spectrum. Here are all the functions that have been included in Etabs. Latest one being for Kyrgyzstan, KR22-2018. So we add a new function, and we can take a look at all the parameters. You can define the function damping ratio. Here are all the period and acceleration values, and you can look at the plots using different plot options here. This concludes all of the new enhancements that are included in Etabs 22.0. Please visit our website, csiamerica.com, for more information. Thank you.